Namaste. Mr. Bowser here talking to you about congruent and similar figures. Um, and then how we're going to use that in our chapter here dealing with proportions. So congruent, we should know that that word congruent means same measure. Right? So congruent figures have equal measures. Everything, all the angles, all the sides, everything is exactly equal measure. So all the corresponding pieces. Now, all the angles are the same. All the corresponding side lengths are equal measure. And we'll see this sign here. So I've got quadrilateral ABDC is congruent to quadrilateral EFGH. Now, it's important, all right, let's get the thing out of here. It's important that I see, notice it doesn't say ABCD, all right, because the way this figure is drawn, ABDC, right, congruent to EFGH. So it is telling me that the A corresponds. And corresponding means it's in the same position but on the other figure. So A corresponds with E. Those are the first letters here, right? And also AB, this side length AB, must correspond, says the first two letters must correspond with EF. Okay? And corresponding is important in congruent figures because that tells me that AB, that side length, is equal to EF. Alright? BD is the two second letters in the figure, and that's going to be congruent to FG. DC, side DC will be congruent to side GH. And then also angle G is going to be congruent to angle D. Angle H corresponds with C, and those two would be congruent angles. If we can zoom in here. Alright, so we see that angle C is 80 degrees, angle H also is 80 degrees. If angle D is 82, that also tells me that angle G is 82 degrees as well. All the angles have to be the same. All the corresponding angles, I should say, should be the same. Okay? Alright. If items are similar, right? Shapes are similar, right? It means that they have the same angle measures. They look very much the same. It's almost like if I took something and I put it on a copy machine and then I hit 50% button, hit 50% copy. Right? Well, what's going to happen is it's going to make an identical shape for me, but it's going to be 50% or half as big as the original. Right? It will be the copy. And so ABDC, all I did is I took that and I cloned it. I brought it over here and I made it whatever the size I made it. Okay, and so it is the same. I just enlarged the shape. All right, so it's an exact copy, but it's enlarged by some factor. We call that the scale factor. All right, the scale factor is the relationship or the ratio of the corresponding side of the second figure, the new figure, compared to the corresponding side of the first figure. So in this case, since A, B, C, D, now notice the difference in these two symbols. This one means congruent to, but only one squiggle means is similar to. So all the sides aren't the same length, but the ratio is the same. Alright, so AB corresponds with EF according to my correspondence here. So that 3 corresponds with 5. So the way 3 is to 5, this one is 5/3 as big as 1. So 2 is 5/3 as big. So it's like I've enlarged it by, multiplied it by 5/3, which would increase it by 67%, 66 2/3 repeating percent. 66.6 repeating percent, whatever it is. Okay. So I can make a corresponding proportion, right? And so I have over here that AB to EF, those two corresponding sides, that ratio is going to be the same as BC to its corresponding side, FG. So 3 over 5 equals 5 over x in this case. And then I go ahead and figure out what that is, 8 1/3 or whatever. So know the difference between congruent and similar, and it's very important that we know what sides are correspond with what. Alright, so corresponding again, same position in a different shape or different location. So if I tell you that triangle ABC is similar to triangle DEF, that means AB corresponds with what side? Correct, DE. BC would correspond with EF, and AC would correspond with DF. So AC here, notice that this triangle looks like it's been, alright, it's been kind of, not only has it been moved over here and shrunk, alright, but it looks like it's been flipped like that. So that's what happened. It's been AC, once you flip it, you see it really is corresponding with that DF side. So the corresponding sides in similar shapes are proportional, so we can write a proportion which will help us solve via our proportions. Okay, our similarity statement is down here at the bottom. Similarity statement is that triangle ABC is similar to triangle EFD. So that tells us what sides correspond with what, right? And I need to write a proportion in order to figure out what the side length of BC is. It's important to know that BC corresponds with the FD side here. So BC, which I don't know, I can call that X or whatever, it's got to correspond with the 16. Alright? And the 5, the AB side, corresponds with EF or 7. Alright, so let's see how I write this proportion. Alright, now, you can write the proportion. The great thing about proportions is you can write them any way you want as long as the pieces match up. So I said AB to BC, that ratio of the first side to the second side of this triangle has got to be in the same relationship or ratio as this first side to the second side of this triangle. Now, I could have also written over here what the ratio of 5 to 7, that ratio is going to be the same as x over 16. And so it doesn't matter as long as the parts match up. So this is, I would say, AB to EF, AB to EF, that ratio is the same as BC to FD. As long as the parts match up, so that's this triangle compared to this triangle corresponding part would equal this triangle over this triangle. They have to be in the same part of the fraction. And then the nice thing about this is both of these are going to give me 80 equals 7x. 80 equals 7x. And you could figure out other ways that I could also write the proportion. When I solve it, 80 equals 7x, and that gives me 11 3/7, or whatever that is, 11.428571 repeating. We know that. Okay, so to solve for DE or ED, that side, we've got to figure out that ED, that's got to correspond with AC. And so I've written the corresponding parts, right, correspondence proportion, that AB over AC, so that would be this side over this side will be the same as 7 EF over ED, which is, in this case, our unknown, or x. So 5 over 12 equals 7 over x. You could have also said 5 over 7 equals 12 over x. You could have said 7 over x equals 12 over 5. You could have said 7 over 5 equals x over 12. Any of those will give you the same corresponding cross products equation, which is 5x equals 84. So x, it looks like, equals 16.8. All right, so we got two similar shapes here, and the y side here is going to correspond with 6.9. The 10 side is going to correspond with 11.5. So this is what we call simple translation. We've just moved it, right? Taken this one, moved it over here, and maybe enlarged it by some sort of factor. The ratio of the second side, corresponding side, to the first side, so in this case 11.5 to 10, right? 11.5 to 10, that is called the scale factor, right? It's what you would have to multiply by everything in the first shape to get to its size in the second shape. Typically, I wouldn't leave it like that. So I'd say the scale factor here is 1.15. Right. So whatever I got, yikes, whatever I got on the first shape, I'd have to multiply by 1.15. So if I did 5 times 1.15, that would give me z. Or I could do a proportion to solve. Y times 1.15 would give me 6.9. Or again, you could say 6.9 divided by 1.15 to give you y. So that's another way to use similar shapes. They're going to have a scale factor. All the sides have the same scale multiplication. All right, and it's the ratio of the second side to the first side. Second shape, 11.5 to the first shape, 10. I want you to go ahead and find A, B, C, Y, and Z. B and C are angles, and A, Y, and Z are sides. Okay, so take a couple seconds, pause this, and find those 5 items, and then we'll go over those. So I set up a proportion for A. I have 10 over 11.5. 10 over 11.5, so the small shape to big shape is equal to small shape 9 over big shape A. Right? And cross products and solve 10.35. B is in the corresponding position with this 70, so B is the same angle measure. Similar shapes have congruent angle measures, so 70. C was a little trickier in that you had to know that C corresponded with this blank angle, but in a quadrilateral, the 4 angles add up to 360 always. So I added up the 3 existing angles that I knew. They added up to be 200. Subtracted that from 360. It gave me that this blank angle up here was 160, so C had to be 160. For Y, my proportion was Y over 6.9. So that, again, that's this shape over this shape equals 10 over 11. Should be 11.5 there, bro. Let's see if yikes, look at that. Alright, so 11.5 Y should equal 69. I don't think this is going to be right, is it? Alright, let me fix that. I'll be right back. Alright, bam. Sorry about that. It should be 6. I had miswrote that. So it's important to make sure we have the right corresponding pieces. And for Z, 10Z would equal 57.5. So Z is equal to 5.75. Alright, last example here. I may have lied about that, but let's see. Alright, this is a pretty common example. We've got a triangle within a larger triangle. And since A is an angle in both the small and the big triangle, it's a shared angle. Both of these have right angles, as we can see by the right angle marks. So both, they have this angle congruent, A, and the bottom angle is a right angle. They're both congruent. So E and C must also be congruent. And therefore, if you've got all congruent angles, you've got similar triangles. And so I set up this similarity corresponding congruence here. So ED, which is the left side of the small triangle, that corresponds with CB, the left side of the big triangle. And this is the part that you must pay attention to. AD is the small side of the bottom side of the small triangle. The bottom side of the large triangle is not 11. It is AB, this whole thing. So we must add those together, and notice it is 20, not 11. So when you write this proportion, be careful about that you use not just this one piece, because 9 is the side of the small triangle. 11 is not a side of any triangle. 20, AB, 20 is the side of that triangle. And then AE or EA, 10.29, that corresponds with AC, the whole thing. So that's X plus 10.29, which I have here. And then I can go ahead and find out what X and Y are. Pause this and then come right back. So here are two things. X should be 11 and a ninth, or 11.1 repeating, and that's Y, I'm sorry. And then X is 12.58 approximately. So notice I've got the squiggly equals kind of. All right, namaste. We'll do some practice on writing and solving these proportions with similar and congruent shapes in class. Thank you very much.